Hey guys, welcome to Pepcoding. So in this video, we are going to discuss another new question of arrays and string series, which is number of subarrays with bounded maximum. Okay. So in this question, we'll be given an array of positive integers of two positive, and then we'll be given two more positive integers, that is my left and my right. So let's consider my left to be my low and my right to be my high. Okay. So we have to return the number of contiguous subarrays such that the maximum element in each subarray lies between our low and our high. Okay. So we have to return the count of the subarrays that can be formed where my maximum lies in my range, that is between low and high. Okay. So let's say first let's take an example, simple example. Let's say I have my array consisting of 2, 1, 3, 4. Okay. This is my array. So all the possible arrays that can be formed here is 2, 2, 1, 2, 1, 3, 2, 1, 3, 4, 1, 1, 3, 1, 3, 4, 3, 3, 4, and then 4. Okay. So here the maximum here is 2, the maximum here is 2, the maximum here is 3, the maximum here is 4, maximum here is 1, maximum here is 3, maximum here is 4, maximum here is 3, maximum here is 4, maximum here is 4. Let's say my low is 2, my R is 3. So I have to check if my maximum of all these arrays lies in my range. So here the maximum lies in my range, that is 2, that lies between 2 and 3. Here also my maximum lies in my range between low and high. Here also my maximum lies in my range. Here also my maximum lies in my range. Here does not lie in my range because it's greater than my right. Here does not lie in my range because it's even more smaller than my left, right? Here also does not lie in range. Here lies in range. Here lies in range, right? Okay. So count is what? 1, 2, 1, 2, 3, 4, 5. So my count is 5. So we have to return this count. This count, that is for this array, I get 5 subarrays whose maximum lies in my range, that is between 2 and 3. Okay. Okay. So now let's discuss about the approaches. Okay. Let's discuss about the approaches that I can solve here. Let me just erase all this. Okay. Approach, let's say 0. That is my brute force approach. This is my brute force approach. Okay. So what do I do here? I say generate all the subarrays. I say generate all the subarrays and then check max if lies in range. And if it lies in range, then count plus, then increase the count. Okay. So if I do so, it is going to take order of n square time, because to generate all the subarrays it is going to take more than order of n time. And then in all the, because let's see, if I have n, I'm going to form n plus n by 2, n into n plus 1 by 2 subarrays. All right. And for all this much arrays, we have to check the max. So it is going to take order of n square time. All right. So we don't have to do this. We are not going to consider this. And what am I going to do? I will use second approach, that is my approach. I name it approach 1. That is my let's say breaking point approach. Let me change the background. Okay. My breaking point approach. So let's say what this breaking point approach says. This says that, let's say this is my array. Let me just erase all this. Okay. This is my breaking point approach. Okay. Let's say I have an array. It has 7, 5, 6, 8, 9, 4, 3, 9, 11, sorry, this is, let's say this is 1, this is not 11, this is, let's say 1. Okay, this is 1. Okay, so if I say my low is 2, my R is 8. Okay, now this is my breaking point. Wait, this is my breaking point. This is my breaking point here, right? Let's say, what does breaking point mean? Breaking point is the element that I have to exclude. It means, because let's say if it were 10 here, okay, this is greater than my right, that is, it is greater than my range, this is also greater than my right, so this is also out of my range. So the element that we have to exclude are the elements that are greater than my right, that does not lie in my range. Okay, now why I am not considering about my element which is lower than my range, we'll discuss it later. So the element that are greater than my right are going to be my must to be excluded, right? That they should be excluded. It is must that we should exclude them from our answer. Okay, so let's say this gives me a count, that is, let's say count 1. This subarray give me a count, that is, count is what? Count is the count is this number of subarrays that we have to form, that we are going to form with these numbers, and whose max lies in our range. Okay, because for all this number we are not having any element that is greater than our right. Okay, for all this element also I am not going to have any element that is greater than our right. Okay, because element that are greater than our right are already excluded. Okay, so this give me some count, and then this give me some count, that is, let's say count 3. So my overall answer will be what? Overall answer will be equal to count 1 plus count 2 plus count 3. Okay, this will be my overall answer. Okay, if we talk about this subarray, let's say all the arrays that are ending at 7, all the subarrays that are ending at 7 are what? Are only 1. All the subarrays that are ending at 5 are what? 5 and then 7, 5. All the arrays that are ending at 6 are what? 6, 5, 6 and then 7, 5, 6. All the subarrays that are ending at 8 are what? 8, 8, 6, 8 and then 5, 6, 8 and then 7, 5, 6, 8. Right? These are my all the possible subarrays that are ending at my 8. Let me just erase this. Let me make it again. What were my array? My arrays were 7. My arrays were 7, 5, 7, 5, 6, 5, 6, 7, 5, 6, 8, 6, 8, 5, 6, 8, 7, 5, 6, 8. All right. Now look at now just see this very clear, like very attentively. Here the max is 7, that lies in my range. Here the max is 5, that lies in my range. Here the max is 5, that lies in my range. Here the max is 6, that lies in my range. Here the max is 6, that lies in my range. Here the max is 6, that lies in my range. Here is the 8 that lies in my range. Here max is 8, that lies in my range. Here the max lies in my range. Here the max lies in my range. So I'm definitely sure that for all these numbers I am going to have all the subarrays that are going to give me some count where my max lies in my range, right? Because I am going to exclude the element which is greater, which does not lie in my range. Okay, so I am going to calculate the count for this point first of all, then count till this point, then count till this point, then count till this point. Okay, so count till this point was what? 1. I can form only one subarray for this point only, because I have only one element. So for this point my count is 1. It means I can form only one subarray whose maximum lies in my range. For this point I can form 2 subarrays, that is, one with 5 and one with 7, 5. Okay, right? So count till this point is 2. Okay, so I will add this 1 plus 2, right? So this is, let's say, my previous count and this is my current count. Okay, 1 plus 2. Now count till this point is what? I can form 3 subarrays, that is 6, 5, 6, 7, 5, 6. 3 for this point, right? And 4 for this point, right? So I'm going to add all this, so the count here is going to be what? my count here will be equal to 3 plus, which will be equal to 10 here. So count for this is 10. Now count for this subarrays will be equal to what? For this 4, the count will be 1, and for this 3, and for this point the count will be 2. That is, it will form 4, then 3, then 4, 3. Right? So there will be 3 subarrays. Now count for this will be what? 1, 2, 1, 2. Right? So I'm not going to consider this and count here is going to be 2, because the max here is 2. Max here is 1. So I'm not going to consider this. So count here is 2, because the max does not lie in my range. So count here is 2. Okay. So what do I have to do? My breaking point approach is, whenever I get any element that is greater than my right, I'm not going to consider this. I will start from this point. I have calculated count till this point. I am going to start from this point. Let's say this is my ending index. I call this index to be my ending index, right? My EI was here. I calculated the count for this point. EI was then come here. Wait, let me just erase all this. Wait. Okay. This was my 10 here. Okay. Oh, all right. So initially my ending index was at this point. I check every element at my ending index. So I will check here. Does it lie in range? So yeah, it does lie in range. So I will calculate some count for this number. I again check, does this number lies in my range? It lies in my range. So I again calculate some count here. I again check this number. If this number lies in my range, then it means till this point I am going to have some subarrays whose maximum lies in my range. I will calculate count for this. Similarly I will check this. It lies in range. It is going to give me some count. I'm going to every time add my count, right? All right. Okay. So and for this point, as this is greater than my right, so I am going to exclude this. I will just simply increase my EI plus plus. All right. I will make my count to 0. I will make my previous count to 0, and my count will, and my there I will be having two count. First will be my main count. Second will be my previous count. That will keep the count of my previous answer. All right. Now I will check for this. I will check for this. Similarly, I'm going to check for all of this. Breaking point means we have to reset our previous count there. Okay. Whenever I get a breaking point, I'm going to reset my previous count, and I'm going to start from some other index. That is, I will change my starting index. All right. Okay. Now let's just have some another dry run. Let me just give you some another example. Let's say this is my small subarray 314. Okay. Let's say here there is some breaking point. Okay. I start from this point. Okay. So now let me just erase this. This is my SI pointing to 3. This is my EI pointing to some new element. Okay, because my EI every time is pointing to some new element, and it's checking if it's checking the values here. There can be 3 possible values: greater than my left, greater than my right. It means greater than my range, or lesser than my left, that is my lower than my range, or in my range. There are only 3 possibilities, that is greater than equals to and lesser than equal to, right? So let's just, this is my starting index. Let's say it is 0. It is my ending index. Let's say it is 3. I check the value here. Okay. So let me just first of all make the subarray still ending till this point, ending till 4. So 4, 1, 4, 3, 1, 4. So let's say my count here is 3, because the maximum till this point is definitely going to lie in my range. So count here is 3. Okay. Now I check here. Let me give you answer. Let me give you some dry run from the brief. Initially my previous count is 0. My count is also 0. Okay. I check here. My EI is also here. Okay. Let's say my EI is initially here. My SI is also here. This is also my EI. Okay. I will check my this 3. Does it lie in range? Yes, it lies in range. It means I'm going to have 3 possibility here. First of all, let me just make all these 3 possibility. Okay, I'm going to have 3 possibility if this element lies in my range. Okay, if ARR of EI is lesser greater than equal to my left and ARR of EI is lesser than equal to my right. ठीक है, this is my first condition. Else if my ARR of EI is even more lesser than my range. Else if my ARR of EI is greater than my right. This is my breaking point. So I have to reset here. Okay. Now let's see. My EI is here. It's checking. Let's set some range. Let's set some range. L is 2 and R is 3. Sorry, R is 4. Okay. Now I check here. Does this 3 lies in my range? Yes, it lies in my range. So what am I going to do here? Now I will calculate the previous count. So my previous count is going to be what? I will keep the count here of the subarrays that are ending at 3. So my count, how can I calculate my count? I can calculate my count by subtracting SI from EI and then adding 1 to this. That is by EI minus SI plus 1. So if I subtract this EI from SI, let's say my EI and SI both are at same position now. So it is going to give me 0, 0 plus 1, which is equal to 0. It means at this point, I can make only one array. Yes, because I have only one element. Alright, because my SI and EI both are at one same position, it means and my number lies in my range. It means I can perform only one subarray. Alright, that is 3. Okay, and its max lies in my range. Okay, so my count is now, let's say 1, and my previous count is, let's say 1 now. Okay, I check this one now. My index EI moves here, my EI is here. I check this one. Is this one in my range? No, this one is not in my range. So let's see here. Number of all the possible subarrays ending at 1 are what? 1 and 3, 1. Okay, so the max here is 1, but the max here is 3. It means this array does not get affected by the lower value of my ARR of EI, right? Because I have, then it means what does it mean? I have to increase my count again to previous, right? It means I have to do here what? Count plus equal to previous. Let's see how. Here I am forming 2 arrays. I can form 2 subarrays, that is 1 and 3, 1. Okay, so in 3, 1 my max is going to be what? This 3, right? This one does not affect because it is even more lower than in my range, right? So the only combination that is we have to discard will be what? Will be only that subarray that is formed by single element, that is my ERR of EI, right? Only this combination will be discarded and baki all other combination can be included, right? So I'm going to increase my count to again previous plus 1. Let's say if this was not for, this was again, let's just give you some other, let me just erase all this. Let me give some more example. Let's suppose it were 2 and it were 1. Okay, let's see this. So what am I going to do here? Let me just erase this 3 and make it more clear. Okay, so this is my 3 to 1. Okay, now my EI is at this 2. This 2 is in my range. All the possible subarrays that can be formed by ending with 2 are 2 and 3, 2, right? And initially we also have one more subarray, that was my 3. Okay, so my count was initially 1. After coming to this position again, my previous count become equal to what? I calculate my previous count because my maximum lies in my range. My number lies in my range, so I calculate my previous count. So here EI was 1, SI is 0, so 1 minus 0 is equal to 1, 1 plus 1 is 2. So my previous count is 2 now. I add to my count, so my count become 3. Right? It means till this point I can form 3 subarrays that has maximum element lying in range. Alright. lying in range low and high. Now I come here, my EI is here. Now let's see what happens. These are my possible subarrays, that is my 3, 3, 2, 3, 2, right? Now I check this. So I now make all the possible arrays that ends at 1. So it is 1, 2, 1, 3, 2, 1, right? So here my max does not get affected by this 2, by this one. It is 2. Here also it is 3, right? Only the combination, only the subarray that includes only this single element, that is the only subarray that is formed with the single element that is lesser than my range, right? That is even lesser than my range. That combination, that subarrays we have to discard. Other two subarrays we can include. That is equal to my previous count, right? Here also my previous count was 2, so it is also equal to my previous count. So it means what? Whenever my ARR of EI is lesser than my left, right? Then what am I going to do? I am simply going to increase my count again to previous count, right? I'm going to add previous count to my count, right? Because here also I can have two more subarrays, right? Subarrays whose maximum lies in my range. Only one subarray that is formed with a single element, that is my element less than my left. Only that combination only that subarray we have to discard, right? Otherwise I have to increase my count to previous. I will again add my previous count to my count. Okay, so this is my second case. Now let's say my EI comes here. Now let me just erase this. Okay, this is my EI. Now comes the case when my AR of EI is greater than my range. Let's say it is 5 here, and let me erase all this. Now all the subarrays ending at 5, all the subarrays ending at 5 are going to be what? 3, 5, 5, 1, 5, 1, 5, 2, 1, 5, 3, 2, 1, 5. Max here is 5, max is 5. Max here is 5, max here is 5, max here is 5. It means I cannot consider even one subarray here, right? Because my max is changed. Because if here comes any element that is greater than my range, that is greater than my right, it is going to be the max for all the subarrays. So we don't have to consider consider all this subarrays, right? So what am I going to do here? I will reset here. Reset means I am going to make my previous count to 0. Previous count will become 0. Okay, then what do we have to do? We will be resetting previous count to 0 and my starting index come here, right? Because this is my breaking point. I don't have to consider this. I will start from here. So my starting index become equal to EI plus 1. Okay, so I will come see for all the elements here now. All right. So I hope I was able to make it clear to you guys. So whenever here we will be starting from my starting of my array and checking every element. Okay, if it lies in range, then we have to calculate all the subarrays that are ending at that point. Okay, if it does not lie in range, if it's lesser than my lower, that is if that particular element is lesser than my left, then I'm going to increase my count to previous count, and only we are going to discard that particular subarrays that contains only that particular element which is lower than my left. Okay, and it means it has only that one element, and that one element is going to be the max for that subarray. So we have to discard only my that count. Otherwise we are going to include previous count to my count. Okay, then comes my third case where my right is where my index element is greater than my right. Okay, that is so my max is going to be equal to my right for all the possible subarrays, right? So we don't have to include any count. We don't have to do anything in my count. I will set my previous count to 0. I will start from some new index. Okay, so let's start code for this. Here I will be having two main thing, starting index which is initially equal to 0, ending index which is also equal to 0, and my count which is equal to 0, and my previous count which is equal to 0, and my let's calculate my n which is equal to ARR dot length. Okay, now I will run a while loop while I reach the end of my array. So it means while ei is lesser than n, do what? Check here. I will have first condition, that is my ARR of ei is greater than equal to my left, and my ARR of ei is lesser than equal to my right. Alright, then what we have to do, we will be calculating our previous count. Previous count become equal to ei minus si plus 1. Si plus 1. Alright, and add this previous count to my count. Alright, else if my ARR of ei is even more lesser than my left. So what do we have to do? We just have to add my previous count to my count. Previous count. Alright, and else my ARR of ei is even more greater than my right. Okay, then what we have to do? We have to reset. It means we have to reset our previous count to 0 and initialize si to ei plus 1. Then return the count here. Increase my ei here, ei plus plus, and return count here. Return the count. Okay, now let's try to run this code. Accepted, and let's try to submit this. Okay, submitted. All the test cases are passed. Okay, so let's try run over this code now. Over the sample input. Okay, so my sample array input is 2, 1, 4, 3, and my low and high are 2 and 3. Okay, left and right are 2 and 3, and my array is 2, 1, 4, 3. Array is, let's say, 2, 1, 4, 3, L is equal to 2, R is equals to 3. Okay, so initially my SI and EI both are here, SI, EI. Okay, it checks if my ARR of EI is in range. Yes, 2 is in range. So what am I going to do here? It will calculate previous count to EI minus 1, EI minus SI plus 1. So previous count was initially 0. Previous count was become 1, and my count become equal to 1, which was also 0. Okay, then my EI comes here. If EI come here, it checks is this 1 in my range? No, it's not in my range, but I'm going to include this in my count, my previous count. I'm going to add my previous count to my count, which is equal to 1 plus 1, 2. This is the case. Let's say, see here, subarrays ending at 1 are 1 and 2, 1. Right? I am going to consider this case, but not this case. Right? Which is equal to my previous count. It means the number of subarrays that I can form here, by where my max lies in my range, is equal to my previous count. Right? When my left come to when my ARR of EI is even more lesser than my left. Okay, so my count become 2 now. Alright. Okay, now my EI increase, EI come here, it checks if is 4 in my range, 4 is not in my range. So I set my previous count to 0 and move my SI to EI plus 1. My SI is here now, and then my EI is increased, my EI is also here now. It checks if this ARR of SI, that is 3, is in my range. Yes, it is in my range. It is in my range. So I'm going to calculate previous count again, which is equal to EI minus SI plus 1. So 3 minus 3 plus 1, which is equal to 1. Previous count is 1 again. then I add my pre count to my, then I add my previous count to my count, which is equal to 2 plus 1, which is equal to 3 now. My count is 3. So I return my count here. Okay. When I increase e plus plus, so my e reaches here, which is equal to my n. So this loop terminates and I return my count. Okay. So I hope I was able to make it clear to you guys. I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.